In this video, we'll look at atomic symbols and the periodic table. When we look at the periodic table, there's a lot of information that we can gather just by where an element is located. And just by looking at the periodic table, we can figure out a lot of information about a particular element. So looking at our atomic symbols. When we have our atomic symbols, there's a few pieces of information we can get right away about that element. First, the atomic number. The atomic number is usually written in the top corner somewhere or somewhere along the top of the periodic table. The atomic number indicates the number of protons in that particular element. And when we look at the periodic table, it's ordered by increasing number of protons. So whenever we look at the atomic number, we can tell how many protons are in that element right away. For hydrogen here, there's 1 proton. Then we have our atomic symbol. The atomic symbol is usually a shorthand for the element. Atomic symbols are typically 1 to 2 letters long, and they become a shorthand version of writing the element out. So instead of writing the entire word hydrogen whenever we talk about it, we can write the capital letter H. And atomic symbols are written with the first letter being capitalized and the second letter is lowercase. And then sometimes on the periodic table, they actually write out the full name of our element. That would be the element name. And then finally at the bottom, you usually see atomic masses. The atomic mass is our average mass of the element. So this is where we take all the masses of the different isotopes and figure out the average of it. And we'll see how to figure out the average atomic mass in another video. So now that we know a little bit about our atomic symbols, let's look at our periodic table. As I said, there's a lot of information we can get from an element just based off of its location. And so we have to learn how to read a periodic table properly. When you look at a periodic table, first thing to note is we have columns and rows. So our columns are also known as our groups. And they go vertically up and down the periodic table. So we'd have group 1, group 2, group 3, 4, 5, 6, 7 to group 18. All of those are different groups. And then we go horizontally. Horizontally across, we have what we call our periods. So we can have period 1, 2, 3, 4, 5, 6, 7 down the periodic table. And so one thing to note, some groups, some columns on the periodic table go by particular names. And you'll hear me say the names of the groups once in a while. I'll call it by its group instead of just the column name. So for example, group 1 is known as our alkali metals. Group 2 is known as our alkaline earth metals. Then in the middle from group 3 to group 12, so all in the middle here, that's our transition metals. And then we kind of jump across to group 17. Group 17 is also known as the halogens. And then group 18, the last column, is known as the noble gases. And the little cutout, the ones you see on the bottom here, these are known as the inner transition metals. So now that we know a little bit about that, a couple other names you might hear is, if we look at our first two groups here, our first two columns, group 1 and 2. Groups 1 and 2, and then also groups 13 through 18. It's kind of the two ends of our periodic table. They're known as our main group elements. And they differ in their chemistry a little bit than the transition metals or the inner transition metals. The main group elements are a lot more predictable in their chemistry. For example, they tend to form ions in a lot more predictable pattern versus our transition metals. So the main groups form their ions in order to get to the same number of electrons as the nearest noble gas. The ones in column 1, the alkali metals, they tend to form a +1 charge, because if they lose 1 electron, they get the same number of electrons as the noble gas that they're right after. So example of sodium, sodium has 11 protons, 11 electrons. If it loses 1 electron, now it has 10 electrons, same as neon. So everything in the alkali metals, they'll lose 1 electron to become a +1 charge. Same thing with everything in group 2. They're going to lose 2 electrons in order to become a +2 charge. So they'll have the same number of electrons as their nearest noble gas. So if we look at calcium, calcium loses 2 electrons. It goes from having 20 electrons to 18, same as argon. So everything in group 2 will form a +2 charge. The transition metals are a lot less predictable in this fashion. For group 3, if it loses 3 electrons, so if I have aluminum and it loses 3, it goes from 13 electrons down to 10, same as neon. So group 13 tends to form a +3 charge. Group 4, it can either gain 4 electrons or lose 4 electrons. It's right in the middle there. So group 14 or 4A, it tends to either be a plus or -4. Group 5 or group 15, if it gains 3 electrons, then nitrogen would have the same number of electrons as neon, because 7 + 3 is 10. So group 15 tends to form a -3 charge. Group 16 or 6A, they tend to gain 2 electrons. So if they gain 2 electrons, they form a -2 charge. So oxygen would go from 8 electrons up to 10, same as neon. And then our halogens, you guessed it, tend to form a -1 charge. Because if it gains 1 more electron, then it has the same as the nearest noble gas. Noble gases are called noble gases because they do not react. They do not like to react at all, so they don't gain or lose electrons. Not so bad, right? So a couple other things about our periodic table. You may notice that we have a dark stair step right here. It's now getting highlighted in purple. That stair step divides our metals from our non-metals. So that means everything over here is a metal. Kind of guessed it from the name of transition metals, hopefully, in the alkali earth metals. So everything over here is a metal. Everything in the top corner of the periodic table here, these are non-metals. Our metals will form cations. So everything in this metal here will form a positive charge when it goes through a reaction. Our non-metals, as you can see, they form negative charges. So this is where the anions are located. And the elements touching the stair step, those are what we call our metalloids. So if we highlight in purple all of our different metalloids, you can see that it's elements that touch that stair step. So all the elements circled in purple here or highlighted in purple, those are our metalloids. They are they have some properties of metals, but not quite all the same properties that metals would have. And then that means everything in green here, these are our nonmetals. Plus hydrogen. Hydrogen's the only one outside of that group that's a nonmetal. So everything highlighted in green, that's our nonmetals. Purple, metalloids, and everything white is our metals. And then one last thing to note about the ones in white. So one last thing to note about our intertransition metals. You can see they kind of are stuck out on the bottom periodic table. They look like they don't quite fit. But if we look at the numbering on the periodic table, here we go from element 57 over to 72. So you can see we kind of jumped the numbers here. This is where the intertransition metals fit, right in the middle between 57 and 72. So this, you actually go from here down to here. And then same thing, you go from 89 down to 90. So that's one thing to keep in mind with the periodic table is we do have this little cutout on the bottom where we go from 57 lanthanide down to 58 cerium. And then same thing, we go from 89 down to 90. They usually put this little cutout on the bottom because otherwise it makes the periodic table really hard to fit on a single piece of paper. It would become a much longer table to read. And so I recommend you write this information down on your guys' periodic table just so you have it around you, ready to look at and use. But now you should be able to read a periodic table and predict the charge of the main group element, and then also kind of tell if something's a metal, non-metal, metalloid, be able to figure out which period it is and which group it is. And then be able to name those different groups for the ones that have a particular name.